This is Mount Kidd, part of the Canadian Rockies, and it's in Alberta. It's a peculiar looking mountain. Let's remove the mountains in the background so we can take a closer look at it. First thing you notice about Mount Kidd is it's folded. I've added a red line to show the folds. The upward fold on the left is called an anticline, and the downward fold in the middle is called a syncline. These folds were formed when rock was pushing upward in the direction of the yellow arrow. The axis of the anticline or upward fold marks the end of the Lewis thrust. The Lewis thrust is a gigantic geologic feature most people have never heard of before, but it's really important to the formation of the Rocky Mountains in Canada. Here's a map that shows the leading edge of the Lewis thrust between Helena, Montana, where it begins, and Mount Kidd in Alberta, where it ends. It's not exactly a straight line. It follows the front range of the Rocky Mountains. Before the Rocky Mountains were formed, the leading edge of the Lewis thrust was in this position. The titanic forces that formed the mountains created the Lewis thrust and moved a huge sheet of rock from this location in the direction of the yellow arrow to its present location. So today, Lewis thrust runs in the direction and location that it does. So what is a thrust fault? A thrust fault is a low-angle reverse fault in which you end up with older rocks laying on top of younger rocks. The Lewis thrust isn't the only thrust fault in the Rocky Mountains. In fact, it's one of many, but it's this pattern of older rocks on top of younger rocks which gives the Rocky Mountains its characteristic geology. Here's a map that shows the major thrust faults in the Canadian Rockies. The Lewis thrust lies between the red arrow and the green arrow. Between the green arrow and the yellow arrow, we have the McConnell thrust and several others that make up the leading edge of the Rocky Mountains. If we look on a cross-section of the Rocky Mountains, just north of Mount Kidd, we see the McConnell thrust, and it separates the foothills from the front ranges. The east of the McConnell thrust, or south of there to the east of the Lewis thrust, we have the foothills. To the west, we have the front ranges. Castle Mountain thrust fault separates the front ranges from the main ranges. So now you know how this peculiar mountain was built and how its geology relates to the overall geology of the Rocky Mountains in Canada.